All right, so today I'm going to lecture over half of this, 6-3. 6-3 deals in vectors. You will need your calculator. Well, yeah, you'll need your calculator possibly. Most of this you probably won't use your calculator. Let me grab my stuff. Okay. So make sure you have your highlighter handy. Vectors are used a lot in physics. And they describe the magnitude and the direction of force and velocity. We can describe area and time and temperature by a specific number, but it's very difficult to describe force and velocity by a number. And so a vector, and this is an example of a vector, this is proper notation for a vector. It looks like ray PQ, and isn't a vector look like a ray from geometry? And so that's why your notation is as it is. And then we have these two things here. We are going to find, well, first of all, this vector P is your initial point, and your terminal point where the vector ends is at Q. So a vector always has a starting point and an ending point. So just like any ray has a starting point and then it goes infinitely through one point, we're going to stop our vector at a specific point. The reason why there's an arrow here is because it's important to know the direction of your vector. And we'll get into that on day 2 of the lecture. But there's some notation that you need to be aware of. So right here, these double lines, which look like absolute value lines, means the magnitude. If the magnitude, which is the length of your vector, is 1, it's called a unit vector. Just like on a unit circle, isn't the length of our unit circle 1 for the radius that goes all the way around? Same thing here. If the magnitude or the length of your vector is 0, it's called a zero vector. And what that really means is that the initial and terminal point or terminal points are at the origin, 0, 0. Now, not all vectors start at the origin, but I'm going to teach you how to convert any vector to what's called a standard vector that starts at the origin. Bless you. Vectors are used in the coordinate grid system, so they're going to look like ordered pairs, but they have different notation so that they're noted as vectors rather than an ordered pair. Vectors, you might want to put over here also that vectors represent motion. That's why I mentioned the words force and velocity. Force and velocity have motion to it, right? It's extremely important that you learn what's called the component form of a vector. Because you're going to have to take any vector, and if it's not in component form, you're going to have to convert it to component form. And so here's kind of an explanation here. It's not my, I'm not crazy, but that does look fuzzy, right? Let me see. Oh, there we go. All right, so we're going to start off with 2 ordered pairs. This is called P and this is Q. You're going to see me change P to I and Q to T. I for initial point and T for terminal point. And that'll make a little bit more sense than using P and Q, but you'll see in your textbook that they use P's and Q's. Only this is your beginning point and this is your ending point of your vector. And they are ordered pairs in the coordinate grid system. We're going to find the component form of the vector. All we do is subtract the x values, right, and subtract the y values, but which one comes first? Is it initial minus terminal or terminal minus initial? Yeah, you always start at the end and work backwards. So you're going to do terminal minus initial, always. And then we end up with this new, what looks like an ordered pair, but what's the difference in notation? It has like these less than and greater than signs, right? And that denotes the component form of a vector, which is different than the ordered pair that you see of the initial point and the terminal point. The parentheses become these sideways V's, right? And then that's what your V vector is. So instead of writing ray PQ, we can call that vector just vector V. It would be a lowercase kind of cursive letter. So there's a lot of different notation in there. So that tells you what your component form is. Then we're going to have to learn how to find the magnitude, which is your length of vector V. All vectors could be named different letters, V, U, P, whatever. What does this look like to you? It's the distance formula. And that makes sense. If I'm finding the length from P to Q, I'm using the distance formula. But it is unlike the distance formula where you can decide which one you want to subtract first. With vectors, you have to subtract starting with the terminal side. And then you're going to end up with some sum under here. Now notice that Q1 minus P1, wasn't that V sub 1? Isn't that what this is? Once you find your component form, rather than take your ordered pairs and plug them all the way back into here, can't you just take this component form and square them and add them together? It's a shortcut. But you can do it the long way if you want to. So you can do it this way or this way. So let's go ahead and go through some problems. All right. So we're going to find the component form of a vector. There's 2 steps involved in doing this. So step 1, you're going to find the component form first. This is step 1. And then step 2, you're going to find the length of the vector. Isn't that our magnitude? And they give you an initial point of 4, 6. So I'm going to call this I sub 1 and I sub 2. Meaning that they both belong to my initial point. And the terminal point 8, 10, so this is T sub 1 and T sub 2. Meaning they both belong to my terminal point. And then I'm going to just do step 1. So to find my component form, I'm going to call this vector V because they called it V. And I like to, when I'm writing it by hand, put a ray above that because it's hard to show italicized when you're writing by hand. And so this is equal to. So I'm going to change my parentheses to those things. I don't know the technical word for it. All right, so then I'm going to take my terminal point. So my x's come first, right, in my component form. So my T sub 1 is 8. My I sub 1 is 4. So I'm going to subtract those, comma. And then my y's come second, so I've got 10, and then minus 6. So doesn't that equal 4? 4? Don't use parentheses, I will mark you wrong, because there's a huge difference between them. So get used to that notation. It's a little weird sometimes. But make sure they definitely don't look like parentheses. All right, so I have my component form, and then all I have to do, I can do it the long way, but I'm going to essentially use a distance formula to find my magnitude. And remember, the notation for magnitude looks like this. Double lines, V, double lines. That tells anybody reading it that it's the length of the line. So I could do this. You won't normally see me doing this. I could do this. And couldn't I put what I have up here? And honestly, it doesn't matter which comes first, your x's or your y's. And then look how much longer it would take me. So I did the square root of 4 squared plus 4 squared, which equals the square root of 16 plus 16, right? Oops, you can't see that. Which is the square root of 32, right? Would that be my final answer? I have 2 16s, don't I? Isn't 32 2 times 16? Isn't 16 a perfect square? So what's your actual answer? Square root of 16 is 4, and then I can't take the square root of 2. So you could go through all of that work, but why? when I could just do it way 2? Why not just do it this way? Immediately take your component form and just say 4 squared plus 4 squared equals, you can skip all of that, 16 plus 16, square root of 32, and then 4 red 2. So you say the stuff. So either way. And you might want to note for yourself, this is a shortcut. Slight shortcut. You use what you're comfortable with. Questions about that? Okay. So it's uncomfortable with the notation. The only thing that's difficult really is the notation. And you do have some studying that you're going to have to do. So you've got 2 weeks to study all of these things. If you actually do your homework and write out, the more you write on your homework, the more likely you are to remember what it is that you're doing. If you don't do your homework, there's going to be a whole lot of information from chapter 6 that you're struggling to remember. Because remember, by the time week after next comes, you have to take the test over this information. And there's a lot of stuff for you to remember, a lot of procedures and processes for you to remember. So it is important that you get that homework done. All right, so let's look at the back. So then I put up here definition of vector addition and scalar multiplication. You'll like this because it's easy. And by the way, you need to fix. Up here, these should be the little pointy parentheses, I guess I'll call them. The V parentheses. So those V's. Those should be V's. Now, if I want to, and this is, the minute you see the V's, you know that this vector is in component form. And this vector is in component form. The purpose of this is to change any vector into a standard position. So for instance, on this one on the back, this means that we start at, we're going to start at 0, 0 in the coordinate grid. Is that where the 2 ordered pairs started at? Yes or no? No. But we're going to start at 0, 0, and then we're going to go to the ordered pair 4, 4. So I took these 2 ordered pairs and I switched them to where the initial point here is now at 0, 0 and the terminal point is here now at 4, 4. That was the whole purpose of your component form, is to change it and get it into that standard form of a vector. So I can take a vector anywhere in the coordinate grid and move it there at the origin. So if you see, like you do here, vectors that are already in component form, they've already converted them for you to the standard form. And so if I'm going to add 2 vectors together, can I just add the 2 x values and add the 2 y values, and I'll have a new ordered pair. So if I'm trying to add 2 vectors, so I might have one vector that goes like this, and another vector over here that's at a different angle. So maybe it goes, no, we don't want to go negative, so maybe it goes this way. And I want to know what is the total distance from here to here, what distance did we actually travel? So we're going to add those 2 vectors together. I could also subtract them. I can multiply them. I can take a scalar multiplication and multiply it through. Yeah. I can also find the negative of a vector. Doesn't it make sense? I would multiply -1 through. And here they're showing you the difference. Do we really need to multiply one of the vectors by -1 to subtract them? You won't see me doing that. All right, so let's do some easy vector operations. All right, so there's my 2 vectors in component form, and we're just going to multiply. This is called a scalar, so I'm taking v and multiplying it by 2. So multiply v by 2. What do you get? 2 times 5 is 10, and 2 times 4 is 8. My online notes are quite a bit more extensive than what I'm showing you here because I'm talking you through it. So if you need to write on here 2 times 5 and 2 times 4 to remember where you got that from, then you need to do that in your notes. Add the 2 vectors together, what do you get? Add your x's and add your y's. Yep. So we get 12 here, and what do we get here? 10. So what it's saying is if I have 2 vectors, one that starts at, this one actually starts at 0 and goes to 5, 4, and this one starts at 0 and goes to 7, 6. And then if I added them together, they should go from 0 to 12, 10. The point ordered pair 12, 10. That's what that's saying. subtract. So take v and subtract u from it. Sometimes they'll do u minus v, so you have to pay attention to which one's coming first. So what's 5 minus 7? Yep. And then what's 4 minus 6? Negative 2. So for this one, you might have to do some interim work because you've got scalar along with addition. So if I were you, I would multiply vector v by 3. So 3v equals, what's 3v? Which order pair? 15 and then 12. And then 2u would equal 14 and 12. I'm just multiplying each of the originals by 2, right? And then if I'm adding these together, can I just add down in columns the way I've written it? So 3v plus 2u is equal to, what's 15 and 14? 29, right? And 12 and 12? 24. Done. So this is your final answer for that one. You're like, can't all my homework be like this? Right? You're like, oh, thank you so much. It does get a little trickier. All right, then you find the opposite of v. That's a tough one. What'd you get? Negative 5, negative 4.
That's what I thought it was.
Well, I said it can get trickier. I haven't given it to you yet. All right. So then we're going to find a unit vector. We put any vector into standard form using the component form, but now we're going to find a unit vector. And a unit vector has a length or a magnitude of 1. So we're converting any length vector into a length of 1. Okay? So to do this, you're going to take the vector itself in component form and you're going to divide it by its magnitude. Or if I took v out of the fraction, it'd be v over 1, right? Wouldn't v be like a scalar? And couldn't you take v and multiply it to 1 over the vector? This is not my preferred form, by the way. I prefer this, and you'll see why in a minute. I'll show you both, and then you can determine what you want to do. So let's look at this problem here. Let's get the whole thing out there. Okay, so step 1. Look at what I've given you. Find a unit vector in the direction of v equals, is this in component form or not? Yes. If it weren't in component form, they would give you an initial point and a terminal point, and you'd have to go through the process of getting it into component form first. So that would come before this. But since they've already done it for us, we don't have to worry about it. And then the other part is you're going to have to verify that the result has a length of 1, and I'll show you how to do that in a minute. So very first step, I'm going to choose, this would be way 1, and this would be my preference. So I'm going to choose to do v over the magnitude. Component vector over the magnitude. So my component vector they've given me is negative 2, 5. I'm going to divide that by, oh, do I know the magnitude? No. But you remember the easy way on the previous one? Can't I just take my component form and square this and square that and put it underneath the radical and add them together? So it would look like this. Negative 2 squared plus 5 squared underneath that radical. So I end up getting my component vector up top. What's negative 2 squared? 4. 5 squared? 4 plus 25? So this is the square root of 29 under here. That's the magnitude. Then we're going to split it up. So hold on to that thought for a minute. So we're going to write a final answer in a minute, but I want to then show you way 2. So this is not our finished answer. I'm going to show you our finished answer in a minute. So then way 2, we could have gotten to the same point by instead using v times 1 over the magnitude. So that equals So that would equal 1, okay, so negative 2, 5, I guess this is the way I'll show you, times 1 over, we'll assume that we use the same work there, right? 1 over the square root of 29. You'll see why I don't like this form in a minute. Here's what your final answer looks like. Are you ready? And I'm not going to make you rationalize your denominators because your book doesn't make you do it. But if it were me, I'd be rationalizing the denominators. But in order for you to get your book answers, they don't. Just saying. All right, so all you're going to do to get your final answers, you're going to take the x value and you're going to divide it by the magnitude, comma, because you're going to get an ordered pair. Remember, we're turning into a unit vector, so doesn't a vector look like an ordered pair with these instead of parentheses, right? So I'm going to take negative 2 divided by the square root of 29, comma, and then 5, your y value, divided by the square root of 29, and then put your v parentheses. All you have to do is take this and split it apart and put it over that. This looks a little bit more, it's like, what do I do? Okay, so I divide this by radical 9, I divide that by radical 9. I much prefer way 1. It visually looks and makes more sense to me. This is your final answer. Weird but true. So then there's a verification process that you have to go through. So now we're going to verify that it has a result, or that this result has a length of 1. How are you going to do that? How do we find the length of this vector? The magnitude of this new vector. This is a unit vector now. How do I find the magnitude in component form of a unit vector? Think my shortcut. Don't we use a distance formula? But can't I take this and square it and this and square it and put it underneath the radical? Yes or no? Okay, so here we're going to verify it. So step 2, verify the magnitude equals 1. So I'm going to take my answer, I'm going to square this one, it's all underneath the radical. So I'm going to take negative 2 over the square root of 29 and square that, and add to that the 5 over the square root of 29 and square that. What's negative 2 squared? 4. What's the square root of 29 squared? Isn't it just 29? Plus 5 squared, 25, radical 29 squared, 29. Don't we end up with a square root of 29 over 29, which equals the square root of 1, which equals 1. So if you're asked to verify that the magnitude has a length of 1, all you have to do is take that final component of the unit vector that you just created and square both the x and the y value and put it underneath the radical. And you found that it has a length of 1. And that's the whole point, is we want to create a vector that has a length of 1. All right, so then flip to the third page. You'll like this even better. You won't find anything from today super difficult. Okay? So then we're going to do a lot of the same thing, but we're going to apply it to the set of imaginary or complex numbers. At least it looks like it. We got an I and a J, right? It looks like it. So standard unit vectors are denoted by, so here's 1, I, 1, 0. That means it starts at 0, 0 and goes to 1, 0. Isn't that a unit vector? And then this one starts at 0 but goes to 1. So are these unit vectors that are what to each other? This one is this way on the x-axis, isn't it? And this one is this way on the y-axis, isn't it? Don't they make a right angle? Isn't that what they're saying? So unit vector, but they both have a length of 1, don't they? So that's why they're unit vectors. Okay. All right, so we're going to look at the component form versus the linear form. You have to know the difference. So if I were you, I would box this out. In order to get what's called linear form, all you have to do is get the vector into component form and attach an I onto the x value and a j onto the y value and put a plus in the middle. Think of it this way. Isn't this on the y, or I'm sorry, isn't this on the x-axis? isn't this being attached to the x value of the component form of the vector? And isn't this one on the y-axis? And isn't this one being attached to the y value of the component vector? So it's that simple. So then example 5, you are to let u be the vector with initial point of 2, 5 and a terminal point of -1, 3. Have they given me a vector in component form? Yes or no? Do you see V's for parentheses? No. So they have not. They've given you the initial point and the terminal point. Can you use initial point and terminal point to find component form? Yes. So before you can get to linear form, you have to have it in component form. And so the question says, write u, vector u, as a linear combination of the standard unit vectors I and j. So what they're saying is they want it in linear form. But to get there, we have to find component form first. So step 1, put into component form first. So I'm going to call this I sub 1 and I sub 2, and this is T sub 1 and T sub 2. Which comes first in component form? Yeah, T. So I'm going to take 3, I'm sorry, because I want my axis. -1 comes first, and then 2. And I'm going to subtract them. And then my y's come next, so 3 and -5. And I'm going to subtract those. I would suggest that you don't do it in your head. Do it on paper, because you can see here that sign errors could be an issue, right? So if I add the opposite, my component form is now it's -1 and -2, -3, and 3 and 5, 8. So that's first my component form. Then, second, I can now easily now put into linear form. And all I do is attach, take -3, attach an I onto it, plus 8, and attach a J onto it. What if the 8 was negative? Would I have -8j? Because I wouldn't want to do plus and negative. So this was the answer that they're looking for. Different way of looking at it. Different notation. So then we're going to take this different notation and we're going to add, subtract, and do scalar multiplication with the linear form. So again, you're going to find that easy. So look at what they've done here. So you've got vector v in linear form and vector u also in linear form. This is the x value, this is the y value, x value, and y value. So if I'm going to add the vectors together, don't I add the i's and then add the j's? What do you get? 6i plus 13j. That's a toughie, right? Now I would be careful on the next one. Careful when you're subtracting two things. So v, right? So I'm going to take, v comes first, so I'm going to take 2i minus 4i, right? Then plus, or actually not plus, sorry, minus my u's, right? I'm actually adding those together. Because I want to take my v's, right? My v's are right here for my x values. So v comes first, my x. But then I'm really subtracting the second one, which is this. So I want to subtract the sum of that. Oops, that's a J. Did I put the wrong thing in there? My eyes. Oh, oops, I totally did it wrong. My mistake. So sorry. try that again. Where's your b? Take the whole b. 2i plus 6j minus a. And then we're subtracting the u, right? So we're just subtracting 4i plus 7j. It is minus. So this is my b, right? And this is minus my u. Late on a Friday, my mistake. All right, so then what do you have to do when you have a minus in front of parentheses? Yeah, you gotta distribute. So I really have 2i, thank you. If you can go find it over there. Okay, yes. Minus a 4i, right? And then I've got plus a 6j, but minus a 7j. Because I distributed that negative. So I really have a negative 2i, and then this gives me a negative j. And again, all I did was take v minus u. If you wrote this one out, just so that you can get some connection with this, if I did v plus u, wouldn't this one have been, my v would have been 2i plus 6j, right? Plus, in the middle of 4i plus 7j, and you're just adding like terms, right? So here's your i's, and here's your j's. What are you going to do for 6b? Yeah, take b and multiply the I term and the j term by 6. So what's 2i times 6? 12i. That's actually a 12. And then what's 6j times 6? Plus 36j. Now be careful with d. So we're going to find 2u and we're going to find 3b, and then we're going to subtract the 2. So 2u equals what? 8i plus 14j. We multiplied u by 2. And then just do 3b. I mean, technically, I guess you could do negative 3b. Do you want to do it that way?
Yes.
Okay. So we'll find negative 3b, and what that means is we're multiplying by a scalar that's negative, right? To b. So what's negative 3 times 2i? Negative 6i. And then negative 3 times 6j? Negative 18j. And then if you do it that way, can't you then just add these down? And so 2u minus 3b would equal, these two are going to give you 2i, and these two are going to give you minus 4j. So if you're subtracting, multiply them by the negative, and then you just have to add at the end. Otherwise, if you multiplied by a 3, wouldn't you have to do what we did here? Put this in parentheses behind a minus. Andy? No, not in linear form. Not in linear form. So that's all I have for you today. Any other questions?